had a quick glance through the topic 2.
Yep.
Would have made sense to me, but I haven't really gone through it properly.
Anyone else stuck on topic 2? Is there anything you want Colin to start?
I'm still working through topic 1 actually.
Yeah. Has everyone else finished topic 1 or?
Yep.
Yeah. What about you, Darren?
Yeah.
Yeah.
Topic 1, I haven't had too much look in.
Yeah, in that. So yeah.
Yeah.
Is there anything you want to revise in topic 1 before you do topic 2? Just because we've got one person, but maybe is there anything that you, or are you confident with what you've uploaded?
No.
So perhaps if you say what you're expecting with topic 1.
I suppose one of the little tricks, I guess, with sizing, especially box cutters, most guys that I'm aware of, you said blue. Blue?
Oh, no, black. Yeah, black or blue. The black one would be best.
We, again, have our roof area that we get our ARO from, and ridge falling down. What a lot of guys do is they'll take the total area, the total length in the areas and things like that, and then they'll just divide it. I guess you working in an office, is that all you just do?
Pretty
So
much.
you get an area and just divide it by the number of downpipes. The problem with doing that is it depends where, especially in a box gutter, where your outlets are located. So if we have, so let's just say that was our total roof. If we decide to put the outlet at this end, then really the size of the box gutter is determined by that entire area. But if we decide to put it in the centre, basically the box gutter's sized just on half that space, and that happens, no matter how many downpipes you put in. So I know a lot of guys just go, well, I'll divide it by 4 or something like that. But all you're doing is actually increasing the size of the gutter for no real reason, especially if you're stuck with dimensions, if you're stuck with sizes. So in our office, what we do, we actually, depending where we put it, we'll nominate that roof area depending on where that actual outlet's located. So obviously work on the worst case scenario for sizing, but depending where it goes so that's something that we see that is not quite the norm. Different with eaves, I suppose, because they're probably flat, you don't have stop ends and things like that. But with box gutters, so if you've sized it that way, I just need to know where you put your outlet on that assignment. Oh, one guy sent it in, he's just giving me dimensions, but so I've sent it back to him and asked him where his outlet is, because he's giving me a size of a gutter, but I don't know on what roof area it's on. Does that make sense?
So if any of you want, in view of the talk here, me to set up a resubmit for assessment 1, that's okay. Just let me know, okay? And then you can redo it, and that's, it's up to you, or you can wait until Colin's marked it. It's up to you.
Yeah, and again, look, you guys do whatever you like in your own office. At the end of the day, you guys are designing and certifying something. It's up to you guys how you want to do it. But if you are stuck with dimensions, if you're fixed between points, then you really need to have a look and see how it can work, because it's not always just straightforward. I've never seen it dead straight. Some are, but not always.
So, you said about dividing the roof up.
Yep.
We've got 4 downpipes, so that's a rough sketch of what I did, and all the box gutter from there to there, and then...
Oh, I said to a maximum of 4. So you can you can have 2 if you want. It's up to you.
Right.
Well, I just given you the information.
Yeah.
So if I was you as a client or an architect and said, mate, I've got these glass partitions all the way down here, the best I can give you is 4 downpipes to the max. You have to design the whole roof around that. So you can do it as 2 if you want to.
Okay.
But I don't care, if it's 2 or 3 or 1.
Right.
But it's just all max. So we're not, we haven't got a whole building just full of downpipes.
Yeah.
So if there's glass partitioning or whatever it is that's in the way, then you design it to suit. So if you get a brief, you've got to comply with that brief.
Okay.
So some like you know, for that size roof, you can divide it into 10 metre sections if you want, which gives you 3 even parts.
Yeah. Okay.
And again, it just determines where you put the outlet. That's all I'm interested in. At the end of the day, is where you sized it on where you put the outlet.
Yeah.
If you want to put it in the centre or at the end, that's fine. But it's just as long as the outlet's sized on the flow coming into it.
Right. Okay.
You got any questions, Chris, or you're fine?
No, I didn't do a plan with mine. I just wrote downpipe at each end.
Yep.
If you want me to do a plan.
No, that's okay.
Yeah.
As long as you tell me it's at the end and
right,
that's the way you've done it, that's fine.
Yeah.
I'll follow it from where you've got it.
Yeah.
It's not a problem.
So topic 1 seems fairly,
Straightforward.
yeah.
Yeah.
Mm-hmm. And a lot of people have been contacting Colin. He's given very generously of his time. So what do you want to talk about in topic 2, the people that have ventured into topic 2?
So there's one, I think someone sent through a question about downpipes and outlets in topic 1. No? No? No?
So do you want to answer that now for anyone that's watching on the video? Or have you answered that?
Oh, well, I don't know what their problem is.
Oh,
That's the only
right,
thing.
yeah.
I thought it was, you know, I know there's no pictures and stuff like that. I mean, if anyone wants any pictures or anything to try and help describe things, then just let me know and I'll put it in. But yeah, I haven't given anyone pictures and stuff. But if you want them, just to make it easier, just let me know what you need.
Yeah, give Colin feedback. He's very keen to make sure that it's good. So what are you expecting in? What about going through the calculations in the second book? What do you think, or not? Volume 2? Is that what you're talking about? No.
Do you just want to go through anything?
Through some of them, I think.
Yeah. Topic 2. Right from the beginning. So coefficient of runoff is what you're.
Yeah,
Yep. So does everyone understand fraction impervious and how we actually get fraction impervious, I suppose?
Impervious is of the material.
Impervious, roads, roofs, you know, it's impervious. So impervious areas of, you know, grass, landscaping and stuff like that, obviously stuff that soaks through. So the runoff on that is less than, you know, hard surfaces, obviously. So, so the fraction impervious is a fraction of the impervious area, obviously. So that's all it is. So if we end up, we have a block of land that's, you know, so many square metres. Used to be an old house on it, and now the developer wants to go and put, you know, a big block of units on it. The council won't allow us, or generally because the size of the stormwater system is not going to upgrade the infrastructure, then, or we need to make sure the runoff is equivalent to what it was previously before they actually developed it. So therefore, we need to work out what the fraction of impervious is. So, which is want to know?
Yeah.
Yes. Yeah. Okay. So, all right. Block of land, and we have a little house sitting on it in the driveway. It's all just grass and landscape and everything else, and hopefully it all falls out to the front, and we have a formal stormwater system in the street. The developer comes along and he wants to then build next to it or on it on the lot. His nice big development. It takes up basically the whole lot of the block with, you know, footpaths and everything else that goes with it. So the area of this site, let's say, I don't know, was 100 square metre house. The whole site was, I don't know, 1,200 square metres.
Can you write a bit bigger?
Thanks.
Good.
Okay, so obviously we have, you know, a small percentage that is basically fraction or impervious areas. Okay, so we, you know, this over the overall site is the impervious area, so the hard runoff. So it'll have all the downpipes and everything else, and it may have a flow of, I don't know, whatever it is, 6 litres a second coming off the site. Once our developer comes on who wants to develop the site, we still have to maintain maybe that 6 litres a second, or council might say you limited to whatever the flow rate may be. So we need to then take that area that we've got, or what we had as a fraction as an impervious area, by whatever that development's going to be. So, if he divides, he sets it up and he's going to do 900 square metres of hard impervious areas, and only 300 is left for landscaping and everything else. All it is just a fraction of the total area, this total site that he's got. So 900 divided by 1200, whatever it works out, 0.85 or something, is our impervious area. Okay, so that's all it is, the fraction impervious between that. So on the table, we have the fraction impervious table. So this all comes out of QDM. I don't know if you guys have worked with QDM before, Queensland Drainage Manual. I don't know what happens in other states, so I can't comment on other states. But QDM was a development that was done for southeast Queensland, and it's what councils work by up here. And it's basically, so if we have let's say we have a fraction impervious of 0.85, 85% of the area. Okay, so basically we go to that table 2.1, which is straight out of QDM. We work out what our 1 hour 10-year ARI is, or we just go to Bureau of Meteorology or whatever it is, and put the site in, the site location, find out what it is. If it was 60 millimetres for the hour, for the 60 minutes, for that 1 hour, and we have 0.85, our fraction impervious is somewhere here, so we just interpolate between the two, and we end up with maybe 0.85 is our fraction impervious, okay, or our CY value. Does that make sense? Mm-hmm. So if we follow that through and onto the next page, all I've done is given you examples. So our 1 year ARI is our fraction impervious multiplied by the numbers out of table 2.2. So 1 year is multiplied by 0.8, 2 is 0.85, 5 is 0.95, and then 10 is 1. 1.05, 1.15, 1.2. Yep. Just multiply it by those, and we end up with our final CY values for the discharge off the site, the runoff site. And pretty much that's all it is. Mm-hmm. And then we just multiply that by our 1 year ARI, 2 year, 5 year, 10, 20, 50, 100, and that gives us our flow rates for the actual site.
Yep.
Is that clear?
Yep.
Yep. Does that make sense?
Yep.
What else?
Probably the next one then, the
Time concentration. Yep. We'll use our same site. We'll just take that. Okay, time concentration depends, and it's all it is just a value from the time it takes for, if we had a site at a percentage 2% fall, it was falling somewhere across there. It's the time it takes for water to land at a point and get to its discharge point. So if we put a building over that, and we have downpipes that are associated with it, and we have a stormwater system that may end up at the same place, that's our discharge point. They all connect in obviously as they come through the site. By the time the water gets in, or whether it's overland flow or whether it's actually into a pit and then piped out, that's the time it takes from point A through to point B. So it may be anywhere between 5 minutes up to 15 minutes generally is all we deal with the smaller lots. So what it means is that with all the rainfall, by the time the water gets to off the roof and into the downpipe, by the time it all gathers and gets to that same point, it's all at a particular point in time. So it might take 15 minutes, for example, if it's a fairly flat site. You know what I mean?
Yeah. And that's based on the worst
On the
run, is
longest
it? On
length.
the longest length?
Yep.
Okay.
It's always based on the time it takes from the water
On the
from the
longest.
furthest point back in. So if we had a graded inlet pit here and we have water coming in from all directions into the pit, our time of concentration could be from here into the pit and then the time it gets out into the system. Because basically by the time the water lands on the ground, so it has a fraction impervious of what could be grass or thick grass or whatever the fraction impervious is, which is just the flow off the type of surface that it's on. If it's thick grass or landscaping, then it's obviously going to take a lot longer for that water to get to a point. So it might take a point, from A to B to get to the pit. Once it's in the pipe system, then the time is obviously going to be quicker because it's travelling a lot through smooth bore pipe and that sort of stuff. So by the time it gets from here to here into the pit, and then from here to here, it'll take a certain time, and then by that time, if it continues to rain for 15 minutes, by that time the system is all the water's reaching the point at all the same time. Does that make sense? It's like if you threw a marble down here and threw a marble here, the marble's going to get to here quicker than what it will because it's further away. But if you keep throwing marbles down, eventually they're all going to get to the same point all at once. So it's basically just a time measure for all the rain to be then discharging through a pipe at a certain time.
Based on the worst.
Based on the worst case. So the example I gave you there in 2 is the same thing. So we have a grass area that, the pervious area, the discharge from the grass is 0.045. The car park is 0.015. So there's obviously differences in flows, whether they're fast or slow. So that's off table 2.3. So for paved service, bare service, and average grass, whatever else. The example I've given you there is if we had a certain point time, 10 minutes is going to take for that particular slope. Obviously, the steeper the slope, the faster the runoff, and just in reverse. So, for that example, our time is 14 minutes. So the rain intensity would have to be falling for a period of 14 minutes across the entire site for the whole time before all of that rain gathered to basically flood the outlet or be all the capacity of the site. Yeah. And it is important to understand that because it's when you're actually sizing, like the roofs and things, we only use 5 minutes. It's the time of concentration. It's fairly straightforward. It's hard surfaces straight off the roof, straight to the system. Once we get down though, we can then start to look at the tables on the ARIs and come back instead of going 5 minutes, we can go all the way right down to 14 minutes and the rainfall intensity reduces quite a bit before then we can reduce all our pipe sizes and everything else to come back to suit. We don't have to go 5 minutes all the way right through and out to the system. Okay, so pipe grades, lengths, distances, all that sort of stuff has to be taken into consideration when you're going from a point. So you have all seen an ARI chart, obviously, I'm assuming. So it starts at 5 minutes and 6 and 7 and right through. So, if you've got 14 minutes, then basically you can go to 14 minutes. Start using that. That's what you're sizing up.
But that wouldn't include downpipes, would it?
No, so I'm saying roofs are 5 minutes.
Yeah.
But you can, again, you don't have to size your entire system based on Q20 or Q100. You can drop your whole roof. The standard only requires us to discharge gutters. These gutters are Q20 and box gutters are Q100. It doesn't say our entire system has to be designed at Q100. We can drop it down, we can put it over grate. As long as we can make sure that building is going to be safeguarded through overflow, from a Q100 event. If it discharges and flows off over the ground, so what? it's going to do it anyway because that's our discharge. So we can take our downpipes, put them above the grate, and we can design the rest of that system with Q on if we wanted to. We don't have to keep going through right through the entire system. I don't know what you guys do, but
Yep.
yep.
Your wetted area here for you.
Perimeter? Yep.
Yeah. Is that the
Peter,
angle?
you in?
You got that angle there. Is that just your water depth?
That's just from the centre of the pipe, just working out an angle
So
of
you
the
just draw it up.
depth.
He's driving cars off and get that angle.
No, it's forget the angle. The angle is just because basically from the centre of the pipe, you can either go up or down. It doesn't matter which way it is. It's the distance, the total distance over what you want, what the depth of the water in the pipe would be. So you're only working out, basically, you're only working out the water depth. There is, if you do want to calculate it, there is an actual table out there that gives you the water depths, and I'm not sure, if it's not in that, then I suggest you probably go on the website and Google Q if you want to find the table. I'm not sure if it's in Q or not. If not, I can give you the table, or yeah, I mean,
Can you just draw it up? Like if that's a 150 pipe and your water depth's 50 mil, can you just draw it up and go from your centre out? Or work the
that's
angle?
right. And work out your angle.
Yeah.
Exactly right. That's all it is.
That's all it is.
That's all it is. Yeah. That's all you're doing. And it is easy to use the charge. Just that the angle, you're always going back and forth trying to work
Oh,
out
you're
the
working
depth.
there. Yeah. I suppose when you're working there, G-size pipes, 150, 100 or 225 or something like that.
Yeah, it depends what you're doing.
Right, yeah. But then your water depth's going to change.
Change. Because your flow rate's going to change. Yeah. Again, I mean, like you know, a lot of guys probably don't do this. We don't do it. You know, we just they're all in. You know, we set them all up in Excel and stuff now, so we just put the numbers in and
Yeah, that's
we don't go through and do this by hands only. So you guys
Got you,
just,
Peter. Good.
understand.
I'll
where
turn
it's
it
all
around.
coming, how we do things at the end of the day. I would strongly suggest that, you know, if you're all proficient with Excel, sort of start to write your formulas in an Excel spreadsheet because it's so much easier and easier than just, yeah.
Can he see you? You in the little box, can you see?
Yeah, no one has started video.
No one
It's
is.
just gone off.
Oh God, he's cut himself off.
He was there for a second. Looked like it on the lounge.
Oh, I've got another one. So this is one from WA now. No one has started video again. Yep, that's Mike. Yep. Okay, Mike and Dale from WA, from the Plumbing Licensing Board in WA. Okay. Sorry about this. I wanted him to set up 2 computers, but only set up 1. Another thing we live and learn. There we are. So has he got a good view of you? That's the important thing. The 2 guys in WA.
Don't know.
Can you see yourself there? You,
can.
yeah, you haven't got your head yeah, but in the corner. You haven't got your head cut off?
Just me here, that's all right.
Okay, you're all right with that? Is that better?
Yeah, that's fine.
Okay, all right. So that's Dale and Mike in WA.
Dale, Mike, how are you? That's the way.
So just tell them what we've been doing.
Okay, I've got a face. Okay, guys, we've got 5 guys in the classroom here. We've just been going through first part, volume 1, so answering some questions, and we're just into some stuff on volume 2 at the moment. So quite happy to go through anything that you guys want to go through.
Volume 2 is fine.
So we're up to page 18, I think.
Yeah, thanks.
What else?
Oh.
Is that 18 and volume 2, is it?
Page 18, the guys are up to, yep.
Volume 2?
Volume 2, yeah.
67% just died. I mean, the new battery.
Well, the chip to get a new fan.
So no more questions. He's answered everything.
No, I haven't really gone through this bit yet, so I don't have any questions on it. Yeah.
So you guys are driving the bus. He's left it to you.
So the guys from Perth have any questions?
Yeah. Mike and Dale, do you have any questions? Don't say they've gone.
Well, the only questions we did have were from volume 1, which was critical height.
Critical depth, yep.
Yeah, the critical depth.
Yep.
The gutter end, or our box gutter ended up at 195 odd millimetres.
What was your critical depth?
In a minute. So our critical depth was 35 millimetres.
This is based on the examples that I've given you?
No, this was ours. This is the assessment 1.
Oh, okay, yep.
Yeah. So that was our base critical depth. And then we got a bit confused why we kept adding, well, we doubled it and then added 3 boards of that.
Yep, sure.
And then later on you added 10 mil to it.
Yep.
And then in the end we got the overflow ended up 195, but we couldn't work out what allows you to make over the overflow the total depth of the gutter.
Yep.
Does that make sense?
Yeah, sort of. So you're fine with the calculations, just do you want me to draw you a picture of why and...
Yes, please.
Try and do my best to get this box going. There's some. An outlet. See that? Okay, so we have our box cutters coming through and we have obviously water flowing in and we have a water depth, which is the critical depth is what you guys have worked out, which is water at a particular depth at this point, which is obviously the water flowing into the sun. Yep. Okay, the reason why it's doubled to the high end, basically, I don't know if you guys did any physics at school. It's a mass, so it's the kinetic energy of the water Okay, so to drive it, to actually force it through on such a flat surface, we need a head of water at one end, okay, regardless of the length of it. Okay, to force water to get it moving, we need to create head over it, to move a mass. Because water obviously is weight, so we need a mass. So basically, all we do is multiply it by 2 for this critical depth, which gives us our head of water to actually force it towards the actual sump. Does that make sense? That's the easiest way to explain it.
Yeah, that's what we lack is instruction when we're doing it. That makes a lot of sense.
So if we have, yeah, so if you've got a height there of 35 mil, obviously, you know, it's 70 mil at the high end. Okay? Then we add our freeboard to the top of it to give you the total height of the gutter at that point. Yep? You got, obviously that wasn't an issue, that was a problem, not a problem? Okay.
That was our initial height of 130 or 120 millimetres, yeah.
Yep, so that's what you got, that's great. So then the overflow itself, the thing with the overflows, and I've seen this on buildings before, you'll have a 150 downpipe. I don't know if you've ever seen it before, but you'll have a 150 downpipe coming down through the bottom here, and then I've seen an overflow of 100 mil out through the side of the building. Now, obviously, unless that gutter is very, very deep, the amount of water you're going to get, I mean, that's an orifice calculation. So from the centre of there up is the head of water that you need to drive it through. Okay, now you, obviously, for that type of overflow to work, you need a lot of head to force it through to be equivalent to the amount of water you got flowing down the downpipe. Otherwise, it just won't work. Or you're just going to flood the place. And that's your insurance on the line. So, all I'm saying in here, with the overflow itself, we normally, in our office, we normally do rectangular because obviously the surface area of that is a lot better than that. And we can just do a letterbox out the side. The reason the 10 mil is because we don't want the overflow to work under normal conditions that we've designed to. So if we're saying that this is going to be 35 mil while it's working, it's pretty pointless putting an overflow in at 30 or 35 mil as well. Because it'll start to overflow when really it's working and what it should be doing. Does that make sense?
Yes.
So the reason for the 10 mil is just to give it a little bit of freeboard to get it up above our normal working height if we're going to put the outlet in that position.
Yes.
Then obviously we have, to get the same amount of water that we want to discharge here, this is completely blocked. We have to then come up with an overflow that's going to work based on still maintaining our freeboard, our 50 mil. We still need to make sure this overflow will carry the same amount of water that we're trying to get down this block downpipe. Okay, we must provide 100% full overflow capacity on a box gutter. Does that make sense?
Yeah, that makes sense.
So the higher we make this, obviously our gutter increases, it can narrow. We make it wider, we can make it thinner and with less head over it and all those sorts of things. So therefore, whatever size you guys want to make that overflow, it's up to you. We still need to maintain our 50 mil over the top to make sure. So basically if we add it all up, we've got our 35 mil, our 10 mil, whatever depth you decide to make it plus your 50 is going to give you an overall gutter size.
Yeah, no, that's good. That 50 answers my question. That we just add that to the top of the gutter. And
so where do you get we're on page 20 of volume 1, which is missing one version of
Page 20, yep.
We've got the 30, just for the 30 mil is what against the normal, is the 30 mil is our 35, is that?
That's correct, that's critical depth, yep.
Plus the 10.
Yep.
And then it's the next 50 that I don't.
The 50's the freeboard over the top. We must have a freeboard. It's for wind action. For if you imagine the water in the box gutter is completely full, and it's blowing a very windy day, we don't want that water to then overflow out of the gutter either. So we have a 50 mil freeboard at all times Some people use more. 50 mil freeboard to make sure that we don't have the wind effect flowing over the top of the actual gutter. So we want the overflow to work to make sure it discharges safely, but we still don't want the water to overflow into the building at all.
Okay, so I've got that here, I've got that freeboard, but you've got another 50 mil, you're filling called head. That's what I don't understand.
I have another 50.
So on the second last paragraph, you've got overflow height, because this is what I did, I used that paragraph there.
Okay. Well, the next one is the gutter. Oh, okay. So what I've done, the 50 is what I've worked out in this example. The 50 mil is the required head over the overflow for that particular size overflow to make it work. That's 50. It could be anything. It could be 30 mil. It could be 40. It could be 100. It's the head that I've actually just used in that equation to tell you how much water is required to allow that overflow to work. That's all that 50 is.
You didn't get it from anywhere. It wasn't double critical or anything like that.
No, it depends on the size of the actual overflow that you're working. So if you go back a little bit, back 2 paragraphs above where I've got my 30 mil, and I've used an overflow size there of not less than 1/5 blah blah blah, a head of water over the overflow outlet of 50 mil.
Okay.
That's where that 50 is coming from.
Right.
And like I said, it could be anything. It doesn't mean it's I've used 150 or 50. Sorry, it depends on what size overflow, where you're going to put it. Determines on. I mean, the overflows. You could have an overflow sitting through the bottom of the sump, which is what I've done on that example. I've got an overflow that sits down through here, and it might finish at the soffit line of the building.
That's what I did, but I still need a clarification how high up it went.
Yeah, okay. So that's my overflow. So in my normal calculation down here, if I needed 50 mil of water over the top of this outlet, therefore I still need 50 mil of water over the top of that overflow to make it work.
Right.
So if I put that overflow, that 150, I make sure it's 45 mil above the bottom of the gutter.
Yes.
Then my 50 on top, plus my 50 freeboard. He's giving me that.
So it was the critical deck
Yep.
plus 50 that you use as a rule of thumb.
Well, the 10 is just make sure that the water doesn't overflow and overflow when it's working normally.
Yeah.
You can use whatever you like. It can be 20, 30. Makes no difference as long as
So
the.
you've got critical depth in this case 35.
Yep.
Plus the 10, 45, yes. Plus the 50, plus the 50 freeboard. That's
Yeah.
right.
So your head of water might be more, might be 80 mil that you
Right.
need to add to the top of that to make sure that it's going to actually operate the same way.
Yeah, because I got 195.
Make sense?
If I think mine was 60 or 70 or something.
Yep.
Yep. Okay. Yeah, that's what I did for what I call a drop overflow. But what do you call that overflow?
This overflow
Yeah.
is just a vertical overflow. There's nothing special about it.
High capacity.
Okay.
A high capacity overflows you can do as high capacity overflows you can do in a sump where you have an outlet here and an outlet here, and you might have a weir that sits in between the two.
Oh, okay.
So you actually that is overflowing over the top. So there's there's a whole heap of different ways you can do overflows. It's not any one particular, but don't do that. The other thing you need to be careful of too, and it's sort of a little bit of it's going to be covered under volume 2 when you understand the sizing of a stormwater pipe, is you need to be also careful when you're doing box gutters, which we've had to go back and fix up on a particular job that I'm aware of, where the guy's gone and installed his box gutter and sump. He's run out of his gutter all the way along in the building and then dropped down the building. Nothing wrong with it, all works fine. What you need to be aware of though is the losses that are inside that pipe when you do that. If you don't, the losses could be enough that you're actually then overflowing that gutter. So if this pipe is running completely chocker full, right through, the losses in there may come up somewhere up here. You've only calculated your head of water from here to whatever. You've now got to calculate head of water over the top of those losses as well. And I actually have seen that on a job where they've done that same thing. They haven't calculated the losses in the pipe, and the actual box gutter did overflow inside. It was substantial damage. And it was only because they didn't actually calculate the losses in that pipe system. But again, that's...
they're contained in part 2, aren't they?
Yeah, the losses in the pipes.
Losses,
yeah. So just be aware of it, that's all, when you are. So if you want to, like I said, there's nothing wrong with doing it, but just make sure you do calculate the losses. So basically what we do on a plan is we'll say, the invert of the pipe has to be a particular depth below the sump.
All right.
So we make sure that if he doesn't do it, it's not my problem anymore. It's his problem. Because if he hasn't installed it to what we told him to do, and he's gone and done it another way and hasn't done it that way and it overflows, then my PI is safe because he hasn't actually installed it as per the documents, and he's gone and installed another way and it overflows and it can be proven that his depth isn't there, then it's not my problem, it becomes his insurance.
So where does that come in? You said if the drop was greater, is that because of the head would push the water down?
No,
The losses, is it?
the losses in the pipe itself.
So if you're stuck for a height there, so can you make your box gutter?
You can do lots of things. You can increase the pipe size itself.
Yeah.
Yeah, I mean, just increasing the pipe size will reduce the losses in the system.
Right.
So the best way to explain, which I do the guys at work, the way you best work friction, if you wanted to understand friction, if you put your finger on the table and rip it across the table real quick, you burn your finger. So obviously, there's going to be a lot of friction, so therefore you're doing it fast. So if there's a lot of velocity in the water, therefore the flow rate's quite high, there's more friction. The bigger it is, there's going to be less friction, and hence why we increase pipe sizes. Not to make the plumber money, but it's just so, we reduce losses as we go.
When you say reduce losses, that means
Frictional losses in the pipes.
Yeah. Gotcha.
Again, like I said, it's under volume 2 as far as the losses in the pipes, but just be aware sometimes you need to carry it over to the actual roof as well.
I've got a question about the size of the eaves gutter.
Yep.
When we work it out at a cross-sectional area,
Yep.
how do you relate to that to a square gutter and a half round?
Yep. It's just the area. It's height times length.
Okay.
So whatever that is in millimetres.
Yeah, so you might have to make one up.
Yeah, exactly. Yeah, exactly right. You might have to get something specially made. Not unusual.
So the answer, just our square millimetres is just what our answer is.
That's right. And obviously to reduce the size of it, it's only getting the eave gutter sizing gets down by reducing the amount of water coming into it. Therefore, we have either to make the gutter smaller, we have more outlets. So we reduce the amount of water coming into the gutter by having more outlets in it, or we have a specially made gutter that is made with less outlets in it. But whichever way you want to do it, I mean, you might be restricted to the amount of downpipe and outlets you can have in a gutter, not through your own way, but there could be architectural reasons why they don't want downpipes in certain positions.
That's what you told us. You said 4 outlets.
Maximum 4, yeah. Yep.
So we ended up with a 1,000 square millimetres. And that's
Yep.
the answer.
Yep, that's correct. So you might have to get something 200 wide by 100 high, or whatever you want to make it work.
So you want us to go that far, or you're just happy with the square millimetres?
No, if you can tell me the size you've got, it'd be good.
Because what we missed that, sorry.
If you can tell me the size or the type of gutter. So if you're going to get something made up, just give me the sizes of it. That's all.
Okay, sure.
Oh, the manufacturers of gutters put out on their websites, there's all sizes out there that they put on. They actually tell you what size square millimetres cross-sectional area the gutter is. But if they don't, then yeah, I mean, just do it yourself.
And do we have some sand overflows for the eaves gutter as well? Exactly the same as the box?
No, the overflow on all leaf gutters must be. Well, you can do it. You can do it two ways. If you're going to get something made up, you can either, if it's going to be something with a high front, for example, you'd have to make sure that the contractor leaves a space between at the fascia, so it can overflow out through the back. But again, we still provide a freeboard, even with an eaves gutter. It's not much, but just to make sure that the water, when it's being designed, is not lapping at the edges. So you might give yourself 10 mil or so below the top of that, below the back of the gutter, if that is the back, whichever way. Obviously it works in reverse. Whichever way you want it, to make sure that we actually, when it's working normally, that it's not overflowing. We don't want people coming back and saying, the whole thing's overflowing every time it rains, when it's normal conditions.
So the square millimetres will be your below the line.
Square millimetres of the gutter capacity will be whatever that height is, by whatever that width is or length.
Sure, no problems. Yeah, good.
Anyone else got any other questions? Or do you want a section explained again?
Just on that volume 2.
Yep.
With these, like the diameter and stuff, what's that in metres, or is it going to be in?
It's normally in metres, so it's 0.1 of the, it's 100 mils, 0.1, obviously.
Yeah.
So it's 10 to the minus 3, power to minus 3. Generally, it's always working in metres.
Always in metres, yeah.
What page is that?
18.
Page 18. Mm-hmm.
On volume 2?
Yeah.
Yep.
Mm-hmm.
For the wetted perimeter or the hydraulic radius? Or?
The perimeter, you got pi.
Yep.
Pi
Pi D, yeah.
And with the velocity, the Q to flow, is that litres a second?
Yep. The area again in metres.
Yeah.
And litres per second.
Yeah.
Mm-hmm.
Did I actually give you examples of those? I'm not really.
No, that's the problem though. I think I was looking at that one.
Okay.
No real examples, so you can't really.
Okay.
Can you put an announcement out with an example? That'd be
Yep. We'll
good.
give you examples for all of them.
Yeah.
Mm-hmm.
Mm-hmm.
Right. You understand Manning's equation, don't you?
Yeah.
So, yeah.
What was that, Manning's equation?
Manning's? Yep.
No,
Never heard of it?
You're just doing the roof drainage subject now, aren't you, Graham?
Yeah.
Yeah.
Okay, if you go to page 16,
Mm-hmm.
okay, volume 2. So the top there is,
Oh, yeah.
that's basically Manning's equation is used pretty much nearly every stormwater calculation you'll do for pipes, overland flow paths,
Right. Okay.
any V channels, driveways, anything that water flows over without pressure, pretty much is Manning's equation.
Okay. So this is his equation. Yeah. Right.
Yep. I think I've given you examples of that, haven't I? I'm not. Yeah, yeah. So on page 17, I've given you basically just a 100 mil pipe, for example, at 1%.
Yeah. Okay.
Just give you an example.
Right.
So when we do this received the assignment,
For
do we start from the beginning and go in that procedure the way you've written it?
no, they're just the criteria I've given you.
Alright, so
You need to follow the procedure as you go through.
yeah, what you do first, what you do second.
That's
what you do
correct.
third.
Yeah.
So did you say that was it, or you have to give us that, or what do you do?
I'm sorry.
What I'm after is what I do first, what I do second, what I do third when I get to work out from start to finish on the assignment or whatever I'm working on.
Yeah. Well, through that first volume, I've given you like basically from start through to the end.
Which one, sorry?
In volume 1, so from the first through to the end is the way you would actually normally calculate it. It's always one for the volume 1. It's always obviously determining the roof area,
Yep.
where the downpipe is going to be situated in that roof area, because it may reduce the size of the gutter. If it's centrally located, then it's obviously half the area of the roof that's falling into the gutter itself, not to the outlet, but to the gutter. So the gutter size is reduced.
Yes.
So we work out the gutter, we work out our critical depths to give us an initial size. We work out our outlet size that we want to use. That then determines our depth of head of water over the outlet. And then basically the downpipe sizing. And then last of all, our overflow position, location, where it needs to go, but straight through, sideways, at the end, whichever way it's going to be. And again, you may be limited to where the overflows may be. It depends. Obviously, you don't want an overflow discharging out the front of a shop front or the front entry of a shopping centre, for example. Not such a good look.
So that's the same. So the second assignment is the same. You still have to start at the roof, work out what's coming down onto the ground.
There's two projects that you're doing in assignment 2. One's basically it's going to be a small shopping centre, so it'll have a roof associated with it. It'll have a car park. Discharging to a formal stormwater system. The stormwater system may not play by the rules, so you're going to have to think a little bit. And the second one's going to be an old block of land that some developers pulled over and wants to put a high rise on it, so we got detention and stuff like that associated with it.
Colin, in assessment 1, we had a 5-minute duration.
Yep.
We had the area over 5 minutes. Why was that selected? Was that
5 minutes is the actual minimum that you normally design a roof system to. Or should a maximum 5 minutes. So it's always any rainfall intensity always starts at 5 minutes. So if you go to the Bureau of Meteorology website, you print out an ARI, for example, off their website, which is, I think I've given you at the front of the book. So if you go to that website, go and have a look. Basically, what we do is we normally go to Google Earth. We go to Google, find the location of the site that we're looking for. We then go to the website, we put in the longitude and latitude of the site, and the website comes up with an IFD chart that we then use for our stormwater calculations. But it always starts at 5 minutes.
that's because the impervious roof? That's the time it takes to get from one end of the roof to the gutter?
It is, yes. Yeah. Obviously you can't really shorten it. You can't make it any longer. You can't make it 7 minutes, because obviously roof's laid, it's a hard surface. So it's not going to take much time for the rain to start to get into the gutter at all.
Any more questions here?
No,
It's good to see satisfied students.
We just keep going through as we were, I guess.
Yeah. Would you be willing to do another one before they start? While they're working on assessment
Yeah,
two,
sure.
is that fine?
If they need it, yeah.
Yeah, yeah. So, will we set a date now? Do you think for that?
Well,
Or?
I'll probably get the assessor signing up first.
Okay, yeah. So let me know when you get the assessment up. Yeah, because there's a couple of. Yeah, let me know and I'll distribute a date to them. So this night suits you guys here.
Yeah. Yep.
Yeah. And these guys in Perth have raced home because they're 3 hours behind.
Yeah.
Right ahead. No, I think they're behind.
4 o'clock.
So, and I'll have this sorted out. I'll have 2 computers next time and a phone charger, which is up in my office. So, are you guys finished then? You don't want any more, or do you want anything else covered? You sure?
No, pretty good for now, I think.
Chris?
Yeah, just those examples, we get those examples.
Yeah.
Yep.
And just on that pipe losses one, I think
Yep.
it's 2.12. I don't think there's an example for that one either.
On the pipe losses?
Yeah, just on that
Yeah, not giving you one there. So the head loss in the pipe system, that's on page 21.
Yeah.
Yep. So down the bottom, example 1. So we've got a 150 pipe, 225 at 22 metres of length.
That's a different equation to the top one, though, isn't it? What's
No.
that?
No, the friction slope is, so basically all we've done is turned for Manning's formula, we normally use the slope. So we you know, it's always Q times AR times S to the half over N. So all we've done is turned it around, so instead of putting the equation of S into it, we're now trying to work out what S is, which is the slope. But it's not, don't get confused by the slope of the pipe, it's not the slope of the pipe. It's the friction loss within the pipe, and it's determined by its length and the flow rate. So if you have a 100 ml pipe, you know, like the previous one at 6.1% is what a 100 ml pipe will run at 1% grade, but that doesn't mean that's the capacity of the pipe. We can load it up to 20 litres a second if we have the head capacity to do it, and that's what our friction loss is. That's what we're working out. So we always size the stormwater system based on that friction head.
Yep.
Okay, that tells us what size pipe. So velocity, and we don't want scouring of the pipe. We don't want to start eating the bottom of it out, and it's just the head loss. So, and if we have a ground level and we have a pipe that's running down here at a certain grade, and it comes up and it's going into a pit, all we need is 150 is our freeboard, and that's, you know, let's just say it was 20 litres per second coming into that pipe, and it's just charging out here somewhere. Our head loss starts from, if it is pipe that hasn't got any other manholes or anything associated with it, it's normally work from the top of the pipe, it's the feet of the pipe, and our hydraulic grade line works back to a point. So if we have that depth of pipe, then our hydraulic grade line back here is what we're working on, that friction slope. That's our friction slope.
How do you get where does the point where the hydraulic?
Yeah. It depends, again, on page 21, sorry, have a look. So for example here we've got a 150, again, if you looked at the chart, a normal 150 pipe is running at, 18 point something litres per second at 1%. Okay, that's what normal flow rate is. But all I've done here is given you a pipe of 150 over a length of 22 metres at 28 litres a second. So our friction slope is 2.42%. Okay?
Where did that come? Where did the 2.42 come from?
From that formula,
That one above it, yeah.
for equation 2.12.
Oh, okay, right.
And then all we're doing is to find the actual friction head, which is that hydraulic grade line head. All we're doing is multiplying the friction slope by whatever length of pipe it is.
Right. Okay.
So, you know, then that's nothing more. So the friction slope on that particular pipe for, you know, that flow rate at 2.42 multiplied by our length gives us a head loss in that particular pipe of 532 mil. Now, when you consider that 150 pipe, stormwater pipe should be, you know, really have a 300 mil cover. It might be deeper. So therefore, you know, if we don't have pits and, for example, you know, we have a roof coming right down and connecting in here, there's no reason why, as long as the contractor clears it all, there's no reason why it can't be up here somewhere.
Right. What's that 100 for? So you got
That's just divided, so it's a percentage. So all we're doing is taking back. So instead of being 2.42, it's like any other percentage.
Yeah.
It's just divided by 100 to get it back to them. No point that we can calculate what. Or you can do 2 by 22 and divide it by 100 if you want, but
yeah.
like any percentage.
So if you wanted to drop that, if that slope went above your pit and going to overflow,
Yep.
you can increase the size of your pipe.
That's correct.
Would be one solution, yeah?
That's one solution, yep.
Say what the solution was.
The solution,
Yeah,
what the solution was.
explain,
Oh,
yeah.
sorry, if you couldn't hear yet. Increasing the size of the pipe is one solution, yes.
Or would you increase the grade?
You could do both. You could increase the grade if you've got the grade to play with.
Yes.
Increasing the grade with smaller pipes obviously introduces more friction. So believe it or not, the friction head actually increases. So possibly, increasing pipe sizes is where you would start. So, and obviously as you keep going down the system towards the outlet, normally the hydraulic grade line works in reverse. So when you're designing a system, it's normally at the head of the line working your way down to the outlet. Hydraulic grade lines work in reverse. You're actually working from the outlet coming back because you're working out your losses right through the system, right to the end, right to the beginning. Because the loss in this from here to here may only be, you know, obviously through there. But from here right through to here is obviously a lot greater as that for the gradient.
So you work from the outlet back.
Always work from the outlet back to where there's a hydraulic grade line. Yeah.
You still having junctions and elbows.
Look, you can if you want to. It gets very complex.
Yeah.
If you're going to design it to like really minute numbers, then I'd suggest you do that. But that's not leaving yourself any sort of any safety margin whatsoever in the design.
Is there a table in the AS3500 Part 3, I think, that does bends and fittings? We're using the site for, I think,
What table?
it's a K factor of
Oh, the K factor. Yeah, okay. Well, the K factor is just the same. It's just giving you what that K factor is just the loss. We've got that in here anyway. So.
So we don't have to worry about them normal course of events.
Sorry?
We don't have to worry about fittings and bends.
I don't normally worry about them. No, I don't design it, so it's I give myself a little bit more of a safety margin there. It'd be like, I guess, asking a structural engineer to design his beam down to the last little millimetre. He's not going to do it. And we won't do the same. We'll make sure we've got a safety buffer in there.
So Colin, in theory, that dotted line is your 2.42%, is that what you...
That's exactly right, yes. Yep. So our pipe could be laid at 0.5%. It could be, 0.5% here, but that could be 2.42% is our friction slope.
Yes.
Anything else, guys?
Yes.
we had a few more of the other people on, we'd get more questions. But live and learn.
Be good to get out teeth and do it.
Yes, and
Come
do
back
it,
and-
and come back, And Colin is answering things. Yeah, I think perhaps use that as announcements in
Well, yeah, I'll try and get up this.
Or I'll give you. I
Try and
can.
work between.
I can. Colin's got his own business. I can give you all the email addresses as a group if you want me to, and then when you can send an email out to everybody when you're answering people.
Group email out.
Yeah, as long as you students don't mind if your email's in there and it's being forwarded. That's what I'll to get permission from everybody, confidentiality and all of that, Privacy Act.
I can just put up and give it to you. And
Yeah, I can
something
copy
like
and
that,
paste it up. Yeah, that's right. Yeah, that's fine. I can do that easily. So, you guys finished, or you don't want to raise anything else, or no? You're okay. All right. And what about Mike and Dale?
I just said one more on page 30, just a little bit more information about the
So page 30.
Page 30, yep. Oh, okay, so just basically the, if you like, overland flow areas for a driveway, yep. What did you want to go through?
draw a diagram.
Oh, okay, yep, sure.
That's all.
I'm going to do this one. I'll do a plan view first, if you like. So, if that's my driveway, I have fall that way, and I have cross fall that way. So someone sent me an email and asked me why do I add the two together. The area of the triangle, so that's our fall longitudinally, and we then have cross fall across the driveway. So there are two different areas that we need to calculate. We can't just go and multiply the whole thing together. It's not possible. So the one I've given you in here is what have I got, 12 metres. So if you like, that's our 12 metre length, and that's 6 metre width across the driveway. So that becomes, again, it's just Manning's equation, so that becomes our area. That's all we're doing. And then the rest of it is, you know, depending if it's concrete, bitumen, stones, grass, depends what they're building their driveway out of. Different flow rates for different surfaces.
And then on, so the next page talks about 300 freeboard.
Okay, so if I'm coming through my driveway here and I've got my house garage sitting in here and my floor level off my house is sitting here, generally if I've got an RL in here of 9, I don't want my water level inside this driveway to be above my floor level inside my house. So I'd give myself a freeboard here of 300 mil.
Okay. It's not how to build an WA, of course, you build it right up ground.
No, they do, but it's all fine as long as we're not using the driveway as our means of. If it's all falling crossways this way, then our 300 mil is really, you know, measuring from wherever our water level is sitting along here back to our. So we've got slope on the driveway. We've got a step between the driveway and the house normally. Don't know what they do in WA, but we normally have a termite height.
50 mil or something.
Yeah, then there's normally a step in the garage. So you generally get to your 300 reasonably easy. And generally, around a house, you've got to get 225 for your ORG and your sewage system. So getting to 300 is not normally an issue. But again, you wouldn't fall your driveways and stuff back into your house anyway, or into the building. You know, a commercial building you will, but not a normal house.
So what dictates that 300 mil? Is Is that just
It's just not. It's like the 150. It's just again, saying to the guys here earlier. I don't know what happens in WA, to be honest with you. But over here in Queensland, we have a what they call the Queensland Urban Drainage Manual, and it dictates, and it's used by all councils pretty much in Queensland, and it dictates freeboard levels and things within QDM.
Oh, okay.
So it tells you the freeboard levels that you need to maintain when you're designing a stormwater system. Again, it's sewage. Sewage is easy. I don't know why it's so high at 225 between the whole thing at 150. You can turn the tap off. Well, I know it's there for the council so they don't get sued, but with stormwater, you can't turn the tap off. So it is really important that you do get it right, because if you don't, and you flood someone's place, it's a legal battle.
What's that, the QDM? What?
Queensland Urban Drainage Manual.
They can access that online.
You can get
can't
it
they?
online,
Yeah,
yep.
it's very easy to get.
Yep, you can download it online, you can download the whole thing online.
I think it was on the reference list, wasn't it? Yeah, I think we put it on the resource list. Mm.
New one's just come out, I think, or 2013 version, I think.
Oh, right. Also, with the flow rates that you were talking about, with the different ones for concrete and grass, and depending on the surface, is there a table in the AS 3500 or something? Or I did notice there was one back here, but where did you source that from?
That'd probably be out of QDM as well. Most of the stuff that I would have got would have been out of QDM for this.
Right. Okay. And is that an extensive list, or it's a fairly?
That's pretty much it.
That's pretty much it. Okay.
Generally, I mean, it works with most surfaces. It's
yeah, you could put it.
Also, the CSIRO, I think, have a building research list. I think they put out as well, and I think that may also have. They're exactly the same numbers.
Yeah.
And I think sometimes they work pay services between 0.011 and 0.015, for example. So, you know, you can either work with the best of the worst. Depends on the finish of the concrete. If it's honed, obviously you can use a better number than if it's just room finished.
Yeah.
But again, we don't design to that.
Oh, yeah.
Give yourself a safe margin.
Yeah.
And sorry, you can.
No, just as a starting point. That's all.
Yeah.
So.
Just, you know, the feedback that someone gave about the references and things like that. And remember that there was one of the guys in Victoria.
Oh, why?
Matthew,
Okay. Where did
Matthew.
I get some of this? Where did I get the calculations for the roof water drainage? I don't know. When I first started my course, or not my course, but starting in the design office, I used to get booklets and photocopy things and keep them, and I've still got them. What the name of that book was called, I have no idea. I know it's out of the UK, and a lot of the stuff that I get today, I'll go to the UK or the USA and go to the websites, and I'll get most of the stuff out there. UK, over there they actually have a full facility where they actually do demonstrations and design this stuff, same as Germany. So they actually have full areas that you can go and see systems working. They can flood them, and so a lot of the calculations that we use, even sewage, doing stacks, for example, there are calculations for stacks, and that all comes basically from the UK versions. So that's where you can go to and get a lot of the stuff if you want it. It obviously takes a little bit of research to go through to find out what you want, but a lot of their stuff is based on, is based on their stuff. And our standards pretty much started based on the UK stuff, obviously, being the first people, apart from the Romans, but first people in the English side of it to actually start doing sewers and things like that. So it all come from that side.
So you're exposing them to more than what they're getting in 3500.
Well, 3500 doesn't have any equations. It just has a graph that says you must fall within this area. If you go outside of that area, what do you do?
You need some tools.
So if you go outside that area, then people then need to go, well, sorry, Mr. Architect, I can't give you that. I've got to give you more downpipes. Well, that's not the case. I did have a question from one of the students, I think Victorian as well. How does he go on about doing this with other professionals, looking at his work, and how does he justify it? Again, I don't know what they do in other states, but in Queensland, we work under the Building Act, is the first cab off the rank. That's state legislation. Underneath that is then the BCA. So now what they've done with the BCA used to call up the Plumbing Code of Australia. Now it's been incorporated into the BCA, so it's Volume 3. National Construction Code, Volume 3 is the Plumbing and Drainage Code. In there it says that we can design to anything we want to, provided we can justify it by calculation. So we don't have to go and use 3500 for a sewage system, for example, and we've done it many a time with Brisbane City Council. We go and justify the size of our sewer by calculation. They are sometimes difficult to deal with, and we've had to get professional engineers to certify our stuff, which is fine. But once they've got it and they know what you do and how you do it, and here goes the same thing. But you go in and we're now recognised, so we don't have to go through the whole process again. So we've justified it a few times, and so we're right to go. But you don't, again, as long as you can, because that's out of the Plumbing Code of Australia, out of the BCA. And that's Australia-wide, that's not just Queensland, that's BCA is Australia-wide. It's the Building Code of Australia. So in that, again, if you read through that, Volume 3, it says some states will have, like Queensland has things for stormwater. It basically says that they've got their own, which is QDM, they've got their own requirements in Queensland. So as long as we fall under QDM, we follow QDM and says we can do this, this is what QDM says, councils will accept it. And it's the same with the gutters. All the code says is we need to make sure we safeguard the property. How we do it and how we come up with it is up to us. Again, it's our certificate, our certification, so it's our PI. It's covering it. But you don't want to set up PIs.
No.
Cost you a fortune if you upset them. Today, touch wood. Come and make a plan. Yes, it is. It is.
So you want to close up now, guys, here? And Mike and Dale, you're fine?
Yeah, we're very happy. Thanks very much for setting up.
Yes, I'm sorry to all the students that couldn't get onto the tutorial tonight. To work hard at that. I think I need 2 computers. Can't manage it all on one. It's impossible. So thanks Colin.
That's all right.
I think it's very much appreciated. So I'm hoping to get this available on YouTube. I'll send an email tonight before I go home. Okay, and just pray and hope. All right. I've been around long enough. 34 years I've been at this, so I know. So good night, guys. See you later, Mike and Dale.
Thank you very much, Nora.
See you guys. No worries. Later.